Hello and welcome everybody. Today we're going to start a new chapter called Quadratic Equations, and the first video in this series will be an introduction to quadratics. Alright, the first thing we're going to do is talk about some quadratic basics. The first thing, a quadratic is a degree 2 function or equation. Now what does that look like? Well, if it's a function, it'd be like y equals x squared or y equals 3x squared plus 4x minus 7. The big thing to keep in mind here is that the largest exponent is a 2 every single time. If it was an equation, we simply swap out the y for a 0. So I could have x squared equals 0, or I could have my 3x squared plus 4x minus 7 equals 0. Once again, the point here, or the thing to watch out for, is that the largest exponent is a 2. The second quadratic basic, all quadratic graphs have a parabolic shape. Alright, so parabolic shape, or a parabola. So parabola is the name you're going to hear a lot. What kind of shape is it? Well, it's this U shape, or a smile, or a frown. So you can see in this first one, it's a parabola going upwards. In the second one, it is a parabola going downwards. When it's up, it looks like a smile. So it's happy, it's positive. When it's going down, it looks like a frown. It's sad, it's negative. Okay, let's focus in on the parabola now. It has some properties I want to discuss with you. The first is a vertex. So what is a vertex? Well, it's the highest or lowest point on the parabola. Now, what would that look like? So I'll draw myself a parabola. So the highest or lowest point, a vertex will have either a highest or a lowest. So in this scenario here, I've highlighted the lowest point. So this would be the vertex. So it'll have a low point only. It won't have a high point. If the parabola looks like this, the negative type, the frowning type, the vertex would be at the very top. So each parabola has one vertex, and that's the highest or lowest point. Line of symmetry, or the axes of symmetry. That's a vertical line that divides the parabola into two equal pieces. All right, so how does that look? So if we have our parabola, we'll have our vertex. Well, the line of symmetry, it actually always passes through your vertex, and it's going to mean that this left side is equal to the right side. So if I was able to fold this, if this was drawn on a piece of paper and I was able to fold it, the parabola would line up with each other. The third property I want to talk about, intercepts, and this is something you've talked about before. Intercepts are not new. So those are the points in which the parabola crosses or touches the x and y intercepts, or sorry, x and y axes. There's a little typo here. Axes. A parabola always has one y-intercept, and it can have 0, 1, or 2 x-intercepts. Depends on how it's drawn. So just give you some examples of this. There's my x and y. I could have something like this. That didn't quite touch because my stylus kind of messed up on me, but that's okay. So that would be my 0 case. 1 occurs if the vertex sits on the axes perfectly. So we'll say this is 0 over here, this is 1. And then 2 intercepts, x-intercepts that is, would occur something like this. And you can see there are 2. Okay? In each case, so you'll always have one y-intercept. And now in all of these, it doesn't show it, but parabolas, as they get longer, they always get wider. So eventually, this parabola has to cross the y-axis. It might take a long, long time, but it will always cross it. Points of reflection. That's a new point that's located by using a known point and its distance from the line of symmetry. Okay, so we'll use this idea when graphing sometimes. Maybe we can use algebra to find some points in the parabola, but then we can use these points of reflection to find other points just to make a fuller picture. So if we had, say, the vertex, I'm just going to say here's my vertex, and then there's my line of symmetry. And if I know that a certain point is 2 units away, from that line of symmetry, then I know that there has to be a partnered point, a mirrored point, 2 units on the other side. And then from there, I can maybe start drawing my parabola. So that's a point of reflection. A maximum or minimum value. That's the largest or smallest value of y along the parabola. That occurs at the vertex all the time. So the vertex is always at highest or lowest point, and then that highest or lowest point will be that y value. So there's my x and y axes. There's my parabola. There's my vertex. Let's say it lines up with y equals 2. So because, so there's my vertex again, sorry. Because it's the top there, that's going to have a maximum, and the max value for this parabola will be y equals 2. If it was at the bottom of the parabola, it would be a minimum. And reminder that a parabola either has a maximum or a minimum. So I can show you the minimum. I stuck with green there. How do I want to draw it? Well, let's draw it like that. And there's my vertex. And that's -2, and we'll say that's lined up with it. So there's my vertex. This would be a minimum value now, y equals -2. All right, so that's a maximum and a minimum value. Domain, again, this is something you've talked about in previous classes in your grade 10 for sure. It's a list of all the x values that the parabola passes through. And then there's range. That's the list of all the y values that the parabola passes through. All right, so we've covered a lot of little details there. Let's do an example. Hopefully that'll help cement some of these ideas. Okay, let's focus on parabola 1 here to begin. So we're going to find the vertex. So the vertex is right here. Now the vertex is not, in this case, it's not a bunch of whole numbers, or it's not 2 whole numbers. And again, the vertex is a point, so an x and a y coordinate. So the x looks like it's about 0.5, I would say. It's about halfway between 0 and 1. And the y value, it's -2 point something, so I'm just going to say 2.2. If you said 2.1, that's fine. If ever you have something like this, a vertex that is not a whole number, we just estimate, make it as close as possible, and we'll be happy with it. Okay, line of symmetry. So again, the line of symmetry always passes through your vertex. So whatever the coordinate of the vertex is, sorry, whatever the x coordinate of the vertex is, that will be your line of symmetry. So it would be x equals 0.5. And I feel like I skipped something there. Reminder that all vertical lines, they have the equation x equals something. So it's always going to be x equals and then whatever the x value of the vertex is. All right, maximum or minimum value. So seeing this vertex is at the bottom, we know it is a minimum value. And again, it is whatever the y value is of the vertex. So y equals -2.2. The x-intercepts, you can hopefully see the x-intercepts right here and right here. This is where the parabola is crossing x-axis. So they would be -1, 0, and 2, 0. Okay, y-intercept. All right, the y-intercept, now it's getting kind of busy on my drawing here, but the y-intercept is right here. So the y-intercept is 2, so as a point it'd be 0, -2 is what I should have said, not just 2, but -2. Domain. Well, unless we have a word problem, these parabolas, these quadratics, they're always going to be infinite, meaning they will use every x value eventually that you can think of. So it's going to keep going on forever in the positive x direction. It's going to keep on going forever in the negative x direction. The way we express that is like that. Okay, XER, x is an element of the real numbers. Range, well, the range is not infinite. We always have to start at our highest or lowest y value and then go in the opposite direction, meaning, if I just draw this horizontal line, that is -2 in the y's. The y's will, the parabola goes to -2 and everything above. So the way we would say that are the y's are greater than or equal to -2. Sorry, 0.2, -2.2, because that is our vertex. All right, so that is parabola 1. Let's shift gears and look at parabola 2. Same idea, just more examples of it. The vertex. Well, I don't know if this is not coming across in your image as well, but it looks like my grid work didn't copy into this PowerPoint. This is the best I could do, everybody. I tried a few times, but the best I could do. So we're going to have to make a little bit of an assumption here. I'm going to say that that is -1, that my vertex. So the x-coordinate is -1. The y-coordinate is at the very top, which ends up being 9. So my vertex is -1 and 9. My line of symmetry, that is, it is a vertical line, so it's x equals every time, and then it's whatever the x-coordinate of the vertex is, so that's -1. Max or min value, okay, so the vertex is at the very top, so then it is a max value, and it's always y equals something, and again, it's whatever the y-coordinate of the vertex is, so that is 9. X-intercepts, okay, you can see one's here, and one over here. My stylus is not being very accurate. I'm sorry, everybody. But anyway, so -4 and +2, so -4, 0, and 2 and 0. Y-intercept, it is up here, and that is at 8, so that's going to be 0 and +8. Your domain, like I said before, unless once we get into word problems, this will change possibly. But it's XER, which means the any X value you can think of. One thing that we'll get, I guess I could introduce it now as well, set notation. There's a more proper way to express this, would be X bar, XER, which means the X bar part right here is just you're introducing what variable you're using. So X's, and the bar means such that, and it follows some sort of rule. And the rule here will just be that it can be any real number. That's a really quick explanation. I'll give you a better explanation when you need or when you need one in the next unit. I'm sorry. Range, same idea. So over here, oh, I've switched back to red by accident. Get back to blue. So the highest y value we discussed was 9, and then the parabola can be 9 and anything below 9. So the way we'd express it is y's are less than or equal to 9. And if we wanted to use the proper notation, now we have this y bar, and we'd have that. Okay? But for right now, just so I don't confuse you, all you need is actually these parts, just to kind of the parts that's actually telling me something. We'll get into the proper form when we start using this notation more. All right, so that's your introduction to quadratics. It's just a few really basic things that I think helps. We're going to then switch into quadratic equations. So we're actually learning about some function stuff here, but we're going to work on some equations. And having this little bit of knowledge just makes the equation stuff make more sense. After the equations, we'll get back into focusing on functions, and that's when we'll explain the domain and range and things like that a bit more. All right, so hopefully this made some sense. If it didn't, talk to your teacher or contact me. Have a great night.